Hello and welcome to my presentation on improving Arctic sea ice prediction with the help of sea ice freeboard assimilation. My name is Imke Sievers and I am from the Danish Meteorological Institution and Aalborg University, working together with Till Rasmussen and Lars Stengsen. Most sea ice assimilation products use either the sea ice concentration or sea ice thickness, or both. Sea ice concentration has the advantage of being very easily measured from space, but having a shorter memory. Sea ice thickness has a longer memory, but we always need to make some assumptions about the snow depths for which we do not have enough measurements, but which we need to calculate sea ice thickness from freeboard measurements. Assimilating freeboard directly has the advantage of having a longer memory, and since the ice model is already calculating the ratio in between the snow and the ice, we can directly put it into the model and use it for our assimilation. I want to give to you a short overview of what we are planning to do and what we have done. We've started with setting up the models and coupling the models, running a reference run. We will continue with investigating different strategies for the assimilation, compare them to observations, and based on that decide on which it might be the best strategies for the assimilation. At the moment, we are looking into assimilating gridded products from Cryosat Freeboard level 3 data on either monthly or weekly basis. Some technical details. The models we are using are NEMO 4 for the ocean, coupled to size 6 for the ice at the resolution of 10 by 10 kilometers. We have made a reference run from 82 to 2015 with a spin up until 92, which allows us to use both IceSat-1 data and Cryosat-2 data to find out the best strategy for the assimilation. And our atmospheric forcing is from the Drakkar group with the DFS forcing 5.2. On the right-hand side, you see some results from the reference run for freeboard in the Arctic, and on the left-hand side, you see some IceSat-1 freeboard averaged over the same time in March 2003. Note that the color bars are slightly different, almost the same but slightly different. We see some quite similar features in the Central Arctic, which shows to be slightly thinner in the modeled data than in the IceSat-1 data, which might be due to some warm biases in the Drakkar forcing, which is using error interim, which is known to be too warm, and also having some biases in the cloud cover. And also too little ice in the Baffin Bay, which might be due to the resolution of 10 by 10 kilometers, which might make it a bit difficult to export ice to Narrow Strait into the Baffin Bay, and also on the east of Greenland, which where in general there seems to be a disagreement between modeled data and observation on how the ice extent is behaving there, which we need to look into a bit more. I would like to thank you for your attention, and I'm looking forward to any suggestions, questions, remarks you might have. Thanks.